Best way to minimize, in fact, test escapes with your analog and mixed signal devices or circuits is to properly test them and check coverage. Tessent DefectSim can do that by injecting fault defects into the hardware and simulating their effects. So it injects those defects within the hardware, simulates their effect, which propagates into the outputs, and all of this is simulated. So in the end, you get an extensive report by the tool with your actual test coverage metrics, a list of undetected defects too, which you can then use to improve your tests and then eventually achieve your test coverage goals and minimize test escapes. It's quite a misconception that you don't need to go through an exhaustive defect simulation. You can actually just do a subset of the entire defect population and simulate a couple of hundred defects with Tessent DefectSim. It's going to report then an actual value and a confidence interval. And time to market in this case is something you can improve by shifting left some of that activity. With DefectSim, you can simulate those defects at design time instead of waiting for silicon to be there and then going through the very long and iterative process of analyzing defects, analyzing the silicon results, going into a round of test generation, performing ECOs, sometimes respins. So all of that is minimized, in fact, shifting left. And that's how you can quickly ramp up to your time to market. For functional safety applications, it can come up with a list of unsafe and untolerated defects. So when you have that list, then you can work on improving the actual safety mechanisms that are present in your chip. It also gives you all the key metrics you need for ISO 26262. So that way you can verify if you're able to achieve your ASIL ratings.